Welcome to the Further Maths Edexcel videos for Mechanics 1. This is the first video in the Collisions in 2D section, 1.1 Oblique Impact with a Fixed Surface. So we're going to start here with a recap of some of the previous work that you've done on collisions. So in a direct collision between two objects, we assume that there are no external forces acting and we consider the momentum of the particles and their masses and velocities. We also are very interested in the elasticity of the objects during the collision and the restitution, which is a measure of how elastic the collision will be, and it's the property of the combination of two materials. We use the coefficient of restitution E to measure the restitution. If E is 0, that means that the objects join together, and if E is 1, that means it's a perfectly elastic collision. So if we have a direct impact with a smooth plane, just when we've been working in one dimension before, we would work out the coefficient of restitution by calculating the separation speed and dividing that by the approach speed. We will continue to do this, but we'll be looking at the two directions I and J. So when we've got an oblique impact with a smooth plane, we can still consider two different directions. We think about perpendicular to the plane and parallel to the fixed plane. E is still calculated as the separation speed divided by the approach speed, and the speed parallel to the plane is actually unchanged by the impact. So in order to demonstrate this, there's a little GeoGebra file, and it's really worth having a look at and trying to change U, theta and E. If we look at this example where we've got an angle of 40 degrees here, an initial speed of 3 meters per second and a coefficient of restitution 0.7, and we can see that the speed after impact is 2.51. Now we know that the speed parallel to the plane doesn't change, so what's being affected is the speed perpendicular to the plane, and we'll look at an example of that. So in this example here, we have a ball of mass m kilograms, and it's being projected towards a smooth plane as shown. The coefficient of restitution is 0.5, and we need to find the velocity and the speed of the particle after the impact. So here we can see the GeoGebra file that we are modelling that situation with, and if we have a look, we can see that the speed after impact is 2.65. So let's have a go at doing it and see if we get that answer. Okay, so in order to calculate this, we're going to need to add quite a lot of information to this diagram and use some notation. So we're going to have acting parallel to the plane, U1, which is the speed initially in that direction, and then perpendicular to the plane U2, which is the speed in the perpendicular direction. We also need to add on V1, which we know remains unchanged. The speed parallel to the plane doesn't change, and V2, which is going to be our perpendicular speed after impact. This is where our particle is going to be heading, with a speed of v meters per second. So in order to calculate these, we're going to use our trigonometry, and we can see that U1 is going to be 4 cos 60, because it's the part of this that is acting in this direction. And U2 is going to be 4 sine 60. Therefore, we know that V1 is going to be 4 cos 60, and V2 is going to be E, which is 0.5, times by U2, which is 4 sine 60. So these are the calculations that we're going to need to do in order to find the different components of the velocity after the collision. So these are our calculations here, and now we're going to calculate the velocity after the impact. So V2 is going to give us our velocity in the I direction, and we can see it's happening in the opposite direction to the initial motion, so it's going to be negative. So we get minus 1.73 I, and then we work out V2, we get the component in the J direction, so that is plus 2J meters per second minus 1. In order to work out the speed, that is the modulus of the velocity, so that's going to be the square root of minus 1.73 squared plus 2 squared, which gives us a speed of 2.65 meters per second, which, if you remember, was the speed we found on our GeoGebra file. Okay, thanks for watching the video, and in the next one we'll be looking at loss of kinetic energy in oblique impact with a fixed surface. Thank you.